geometry. Everybody always says, well, if we're not supposed to use the math until we know how it works, then why didn't we have geometry in elementary school so that we would know why all the stuff we do works? Because you can't understand geometry until your brain gets developed to a certain spot. And it's the same thing with this. You could be taught how to do composition, but you're not going to understand it until later on. And this is later on. So here it is. Oh, come on. You're making this anticlimactic. So that only took way too long. For that drum roll to come up. New mathematical operation. You've added, subtracted, multiplied, and divided. And this one, apparently there were a couple of mathematicians in the world that came up with it at the same time. Because usually what happens is people name stuff after themselves in math if they discover it first. But this one's so profound, we don't know. 1 or 2, 3 of them came up at the same time. So here it is. Composition. Add, subtract, multiply, divide, and composition, which is compose when you talk about it as a verb. So composition. Again, it's not incredibly difficult. It's something you do and have already used in the past. You just didn't know that it had a fancy name. So it's got a fancy name. So our key concept here is to figure out what on earth is the composition of functions. You can think of it exactly like you would if you were in a music class and they were talking about composition. Got to get the phones put away or I'll take them. Put the phones away. Pay attention, this is brand new. Composition of functions. Composition of two functions means we're going to take a function and we're going to put it inside another function. That's what we're doing. It's like if somebody is writing a composition, they're putting together, hey, here's all the music, here's all the words, let's put all this together on one sheet of paper. And composition is putting these together. So the composition of function g with function f is written as, and it looks like a little degree bubble, a little donut hole. That's one way to write composition. And that's read as g of f. G of f. So we could write that as g, little donut hole, f of x. Or we could write it with embedded parentheses. Now, you're going to see me write this with embedded parentheses. Because at this point in your education, you've heard me say this before. We need to know that we work with innermost parentheses first and work our way out. So like I said, if we think of composition as embedded parentheses, we're really not learning anything we haven't done before. Because this will be substitution. Do you remember talking about the property of substitution in geometry? We substitute in here all the time. I give you something like this and say, I want you to find x equals 5 for me. You substitute it in for the x and you tell me it's 9. So we just never knew there was a fancy name for that. And the fancy name is composition. So the key to this, again, it's not going to be difficult math, is that we have to talk about the domain, which is what we were talking about yesterday. But this is almost easier because the domain of g of f consists of the x values in the domain of f, for which f of x is in the domain of g. Now they just made that sound really horrible. Here's what we have to do. We only care which function is going into the other function because domain is about inputs. So when I look at these embedded parentheses, I realize, well, f of x is going inside the other one. So all I care about is the domain of f of x. That's the one that's going in. That's the input, the domain. And like I said, two ways to write it. G of f of x, you're going to see me rewrite it for you. G of f of x. And notice the coloring here. Number 1 in the orange says, do this first. Innermost parentheses, work your way out. That's what we have to do. Function composition is not commutative. If you do f of g of x and then you do g of f of x, you don't generally get the same thing. So we have to be careful about that order. F of g of x, very different from g of f of x. All right, let's get started on figuring out how to do this. Let f of x equal x minus 5 and g of x equal x squared. What is g of f of negative 3? The first thing I'd have to know is this in the domain? I mean, because this is telling me I have to put negative 3 into f first, and I'm going to get an answer, and then I'm going to have to put that into g. So rewrite it in the parentheses. The last variable we see is always the one that's going to go right in the middle. Now, in order for that to work, I have to know the domain of f, because f is the one that I'm going to put things into. So let's look at f. Domain of f. Do you see any division? F doesn't have any division. Does it have any even roots? Well, this is excellent news. That means the domain is all real numbers, because that's the input. So the domain of g of f of x is all real numbers, which means we're safe putting in a negative 3. Absolutely safe. So now I want to do what this told me to do. Innermost parentheses first. So here's step 1. I have to take negative 3 and I have to substitute it into f. All right. Negative 3 minus 5. It's negative 8. That was no big deal. But now I have to keep going, because these parentheses tell me once I've figured out f of negative 3, that has to go into g. So now I take my negative 8 and I have to put it in there. So that means I'm going to have negative 8 squared, and I get 64. And now I'm done. That's my answer. I did everything they asked me to do. I put negative 3 into f, got an answer, then I plugged it into g and finished it up. That's composition. It's basically just substitution, putting a function inside a function. So, there have been a lot of questions this year about the MCAs. We received notice from the state, juniors, you absolutely will have to take the MCAs this year. And that's because the federal rule is that the act is called No Child Left Behind, that we are supposed to test every single year. And we got off of it last year because of the big COVID outbreak in the spring. But this year they said, no, everybody's going to have to take it. So juniors, one of the things 10 years ago they said, we're going to take this off of the test because it confuses students, is this gridded response. When you take the test and you do this problem, you're going to look down and you're going to see that goofy little thing right there. Now their goal is to have the MCAs totally computer graded, but they don't want them all to be multiple choice. So they put this on there. Now here's why I have to show it to you. If you put 6 and 4 all the way to the right and you shade in 6 and 4, you're getting credit. You did it right. You got the right answer. If you start over here on the left, 6 and 4, you'll get full credit. It was the right answer, and the computer read it. You do this. No credit. The computer only reads if you start with your answer at the beginning of the left-hand side or if you finish all the way to the right-hand side. It won't read in the middle. So if you have gridded response, it's been on the test the last couple of years, just make sure you either stay all the way to the left or all the way to the right. Don't write stuff in the middle because you're going to have the right answer and the computer's going to mark it wrong. So got to take a look at that every year. And last year we didn't have to do that because they didn't have to take the MCAs. But you guys are back on for the MCAs. All right, this one says, what is f of g of -3 if we still use the same functions that we had up here? So I am going to clone this little bugger and bring it down here. Now, I just read it off, but people have trouble with this when it's written this way, and I don't want anybody to have trouble with composition. It's not supposed to be hard. So when you read it off, you need to say to yourself, so the closest thing to the last variable I have to do first. So I have to find g of -3 first. Once I have that, I move outward, and that's going to be f. And like I said, over the years, I found everybody can figure this out because we know innermost parentheses first. But it's this that kind of messes with people a little bit. So the first thing I have to do is figure out whether or not G has some kind of restricted domain, because that's the one I'm supposed to put things into. So here's G. Take a look at G. Do you see any division? Nope. Any even roots? Well, then it's all reals. So that means this composition, D of f of G, also has a domain of all real numbers. So with composition, we just check the input. That's the only one we pay attention to, the input. Now we can actually do the math because we know it's okay to put -3 into this thing. So which one do I put it into first? G. So this goes here. What's -3 times -3? 9. Am I done? Nope. Now where does it go? Into F. So what is my answer supposed to be? Yeah. Composition, using those two functions at once to figure out what we have. So everybody feel like they're going to be able to do that? Because that's the start of composition. Just figuring out, hey, which one do I put this in first? How does that work? And then we get to this one. And this one says we're going to compose functions, but we have to identify the domain. Obviously, we've been talking about that. Let f of x equals x squared minus 4 and g of x equals x plus 7. Find f of g of x and find the domain. I don't know about you, but I'm looking for a number to put in. I like that last problem we did. We had a number, we put it in the innermost parentheses, then we put it in the other one. This one's saying no numbers this time. Actually put the function into the other function. That's what we're supposed to do. Okay, so I'm supposed to take g of x and put it into f of x. Where? Well, where would we normally put numbers into this? If I said I want you to evaluate this for 3, where would you put the 3? We're going to have to put the whole function in for x. This will go here. And then we'll simplify it. But before we do that, we need to think about that domain. Which one is the input, f of x or g of x? G of x. So the domain of f of g of x is all about what could we put in g of x. So let's look for restrictions for g of x. Anything we have to leave out? Nothing. All reals. So if the domain of G is all reals, the domain of f of g of x is all reals. Now comes the math. I have to take everything in g of x, which is all of this, and I have to put it right there. So it's going to be x plus 7 squared minus 4. And then we'd have to simplify it. But we've been adding, subtracting, multiplying, and dividing, so this is not new math. We know that this 2 goes to the closest thing to its left, which is parentheses. So we'd write them out twice. Then what would we do? Yeah, FOIL. Anything else left to do? A little simplifying, yeah. There it is. This is f of g of x. We created a new function by putting a function inside another function, by substituting that function inside the other function. That's composition. So most people think this is like the hardest problem possible with composition. Doesn't seem that way. You doing okay? All right, so let's talk about another one. This time we have f of x is the square root of x minus 3. I don't like that blue line right there. Let's try that. And g of x as x plus 2. And we are supposed to find g of f of x. And of course, talk about the domain, but we're going to do that first. Which one is the input? F of x. Is that going to have domain restrictions? Yup. It has a square root. And we know you can't put negatives in here. So yesterday we found out what we have to do is set that greater than or equal to 0 and then just solve it. I don't think that's hard to solve. What would you do to solve that? Exactly. So this new formula that we're coming up with, because the domain of f is x has to be greater than or equal to 3, the domain of g of f of x also has to be. Because that's the input. Notice we aren't even bothering to figure out what the domain of g is, because that's not input. We just need the input. All right. Help me out here. Which one goes inside the other one? Where should I start? F. This has to go there. Okay? So square root of x minus 3 plus 2. Can we simplify that? One's the square root and one's not. We can't even put them together. We're done. That's the composition. So this is g of f of x. You had a couple weird ones like that yesterday when you were working in class. I remember some people would call me over and they'd, I can't simplify this, Cedarholm. All I did was put one over the top of the other. Am I done? Yeah, sometimes that happens. Sometimes all we can do is put it where it's supposed to go and say, hey, there's no more math. That's it. Now, these are where we talk about the IZOD problem. These are where we talk about the, hey, I've got a coupon and I've got this percentage discount thing. What can I do? One of my daughters works at Bath and Body Works in Coon Rapids. They are known for big, flash sales of this, that, and the other thing percentage-wise. And she gets a discount because she works there. And there are coupons that come in the mail. And so it's always, how are we going to use all this to save the most money? Well, this is a good one because you got lunch coming up, although some of you just ate your breakfast, for goodness sake. You've got a coupon good for $5 off the price of any large pizza. Ooh, that's a good coupon. You also get a 10% discount on any pizza if you show your student ID. Ooh, that's a good deal too. How much more would you pay for a large pizza if the cashier applies the coupon first? Oh, we don't want to pay more. We want to pay less. So let's see. Anywhere in there, did it say how much my pizza costs? So that's my unknown. That's my X. All right, so I want to look at it both ways. So the first time I'll do the coupon first. And the second time I'll do the discount first. All right, coupon first. I see how much my pizza costs. I get to subtract $5. Then I get to take 10% off the price of the pizza. Well, while that's good to know, that's not what we care about. If we don't have to pay 10%, how much do we have to pay? 90%. So I'm going to have to pay 90% of this. Well, to find 90% of something, you take 0.90 times whatever it is. So this can be simplified. We can go ahead and distribute this. So we've got 0.90x minus, you do that math in your head since it's money, or do you want it up on the screen? Nobody answered, which usually means you want it on the screen. Yeah, 450. So that's what we have to pay if we do the coupon first. Devon, I wasn't kidding about the phones. Put it away. Discount first. Well, that would mean I'm paying 90% of the cost right off the bat. Then they take the $5 off. Any math we could do with that one? So which one of these is the better deal for you? The one on the right, the blue one. Yeah, because this is 90% of the cost and they only end up taking off $4.50 when you do the coupon first. Don't do the coupon first. Do the discount first. How much more did you end up paying if you didn't do it that way? 50 cents. You could just put 0.9. Yeah, you don't need the 0. I try to make sure everybody knows why I've got 90% up here and then it suddenly becomes 0.90 instead of just going to 0.9. All right, well, that was a good deal. Here's a better discount. A store is offering a 15% discount on all items, and all employees get a 20% employee discount. Write the composite functions. So we'll have to do 15% first, and we'll have to do 20% first. And we'll see how those two differ. So let's think. If you get 15% off, how much are you paying? 85%. So that's how you're going to figure out how much you're paying with 15% off. But then, and I didn't leave myself enough space out in front here, you get another discount on top of that, right? So if you're not paying 20%, you are paying 80%. Well, that math we can do. We can just multiply those two together. So let me show you up there, 0.8 times 0.85. 0.68. So this is very similar to the IZOD problem, except not the really deep discounts that they had. So you're going to end up paying 68% of the cost, 32% off. Let's go to the 20% first. All right, remind me again. If you're not paying 20%, you're paying how much? 80%. And then after that, you get the 15% off, which means you're paying how much? 85%. Wait a second. 0.8 times 0.85 is going to give you the same answer as 0.85 times 0.8. So what was the point of this? The point was to show us that if they're both percentage discounts, it doesn't matter which one they do first. The difference comes when you have coupons, because that's taking money right off the top of what you owe. But when it's both percentage discounts, it doesn't matter which one goes first. So A was model the 15% discount, then do the 20%. That was this one. B was 20% and then 15. And C is, if you were an employee, which discount would you take first and why? Well, you'd know better and you'd say it doesn't matter. So now this makes the IZOD one go much faster, because you realize, well, if it says 70% off, I'm paying 30%. And then if it says I get 20% off, I'm paying 80%. Oh, I'm really paying 24% of the cost. Once you know about composition and how to use it, then it goes really fast. So this section, especially this new operation that we have, is really usable, out in the real world, trying to figure out what should I pay for this, that, or the other thing. That definitely is a skill everybody needs to have. So hopefully you already did that one yesterday's. We have now covered all the notes for 6-6. So this will be another Friday where you don't have to watch a lesson video. This is the one for tonight. The red one is the one for tonight. The blue one is for tomorrow, Friday. And they're on Schoology. But there they are. And we have a good amount of work time.